Do you want to return to Monkey? To return to a more primitive way of life and away from the everyday routine of society? This meme, Return to Monkey, tries to move us backwards through time, not that unlike researchers interested in the earliest stages of human evolution. But although we can't actually return to Monkey, that doesn't mean both you and researchers can't take away an important lesson from this concept. By looking backwards through time, I discovered I wanted to research paleogenetics and paleoproteomics. And researchers discovered amazing things about the earliest potential hominins around 5 to 7 million years ago. So sometimes you have to work backwards to discover amazing things about yourself, whether that's you as an individual or all of us as a species. What is a hominin? A hominin is a primate species which is more closely related to humans than our closest living relatives, chimpanzees and bonobos. But while we know what defines a hominin, there is significant debate on what defines a human. Some people use the word human interchangeably with hominin. Some use it as just our species, and anywhere in between. This makes classifying hominins quite difficult. And if you want to learn more about why, I made a whole other episode about it, right here. Even with a solid understanding of what makes something a hominin, trying to figure out what the earliest ones were like is difficult because we know little about their distribution, environment, and appearance. So if we want to make this discovery, we have to look backwards through time to when researchers were trying to do the same, to better understand not only our past, but also our present. In the 1990s, researchers were desperately trying to figure out which species was the first hominin, right after the split between us and chimps. To help them, they used something called the molecular clock. This concept uses the fact that random mutations, changes to the genome, happen at a relatively constant rate of time, just like the ticking of a clock. So by measuring how many of these random mutations there were between two species, just like counting the seconds of time, researchers were able to estimate the evolutionary age of when those two species diverged. From this, they estimated the first hominin to be around 5 to 7 million years old. And during the 1990s, the oldest hominin discovered was Australopithecus ramidus, found by Tim White in 1994. It lived only around 4.4 million years ago. So based on the molecular clock, researchers thought there were probably older hominins waiting to be discovered. But scientific discovery isn't as easy as asking, what's the oldest fossil? Because as we look backwards in time, the traits that make hominins and us unique are going to be harder to spot because they're only just emerging. So they're less pronounced and possibly different from the ones today. That's why there's intense debate on whether some especially old fossils are or aren't hominins. So researchers refer to them as potential hominins. But while we may never have a fossil of the first hominin, we could still use other lines of evidence like ancient ecosystems, paleoclimate, and the potential hominin fossils we do have to instead ask, what was the oldest hominin like? To discover information about the fossils we don't have. And by looking backwards through time to do so, 3 rapid-fire discoveries were made that changed our understanding of our ancient past. Our first discovery was in 1997, when Johannes Haile Selassie discovered our first potential hominin, Australopithecus cadava. It was dated to have lived around 5.8 million years ago. and it was unearthed in Ethiopia in the Middle Awash River Valley in the Afar region. The sediment around the fossil revealed that although this region is now a savanna and desert, around 5.8 million years ago, it was relatively wet and wooded, and changed due to various tectonic, volcanic, climatic geomorphic processes. Most notably, one of the fossils was a single toe bone. It is broad, robust, and most importantly, curved, which is evidence that the species was bipedal, since a curved foot allows for easier forward propulsion as you walk. However, some researchers argue Australopithecus cadaver is not a hominin, due to its primitive traits like 4 cusps on a molar instead of 5 like humans have. Also, researchers argue other extinct non-hominin species may have independently evolved early bipedalism, meaning bipedalism may not have been a uniquely hominin trait, and the evidence of bipedalism does not automatically make something a hominid. However, this is very much up for debate, even among experts. Just 4 years later, Martin Pickford and Bridget Senoot discovered another potential hominid in 2001, Auroran tugenensis. This fossil was dated to have lived around 6.2 million years ago, roughly 400,000 years earlier than Australopithecus cadaver. It was unearthed in Kenya in the Tugen Hills, and the sediment around the fossil revealed that although this region is now a savanna and desert, around 6.2 million years ago, this region was a mosaic forest woodland. Most notably, one of the fossils found was a femur. It's angled towards the center of the body, and has a prominent head that connects to the hip, just like in modern humans. This allows for more centered and stable locomotion when walking on 2 legs, meaning that being bipedal could potentially be a trait that is over 6 million years old. And by looking at the humerus, as well as the bones of the foot, researchers discovered that it was capable of climbing trees too, meaning that Auroran tugenensis may have spent time both in trees and on the ground. However, some researchers argue Auroran tugenensis is not a hominid due to its primitive traits, like the absence of an elevated crown shoulder on its canine, like all other hominins have. But like many things in science, the debate is still not yet settled. Finally, just a year later, in 2002, Michel Brunet discovered our last potential hominid, Sahelanthropus chadensis. This fossil was dated to have lived around 7 million years ago, and is the oldest potential hominid found to date. It was unearthed in northern Chad, and the sediment around the fossil revealed that although this region is now the Sahara Desert, arid and dry, around 7 million years ago, this region was a mosaic of forest woodlands, humid grasslands, and swamps. Most notably, one of the fossils found was a cranium. It was distorted from exposure to the elements, but a virtual reconstruction shows the foramen magnum, which is the hole that the spine connects to the cranium. In Sahelanthropus chadensis, it is positioned more towards the center. This lets the cranium rest more directly on top of the spine when walking upright, and is a major feature researchers look for in the transition from quadrupedalism to bipedalism. However, some researchers argue Sahelanthropus chadensis is not a hominid, due to having primitive features like similar canines to chimps and similar molars to non-hominin apes. Also, researchers argue that any similarities Sahelanthropus chadensis shares with hominins are due to convergent evolution, or homoplasy. This is when 2 animals living similar ways will evolve similar anatomy, but independently rather than from a common ancestor. They argue that Sahelanthropus chadensis was more like non-hominin apes, and the similarities to early hominins was due to this convergent evolution. Looking backwards through time allowed researchers to expand their understanding of early hominin evolution. And using these 3 potential hominin fossils together allows us to paint a broader picture of early hominin evolution, from where they lived to how they moved. The earliest potential hominins weren't all living in East and South Africa, but rather more in Northeast and Central Africa. These environments weren't all open savannas, but rather a mosaic of wet and wooded biomes, much like forests. And these earliest potential hominins weren't all exclusively swinging through the trees like their ape ancestors, but rather able to walk, if not completely, then mostly bipedal on branches. And just like researchers made these discoveries by looking backwards through time, so did I in my own life. In 2022, right after I was about to graduate with my bachelor's degree, I was desperately trying to figure out what I wanted to research. I knew I wanted to do something with molecular biology, and knew there was something out there that I would love to research, but don't know what yet. But again, self-discovery isn't as easy as asking, who am I? Because I'm more than just what I want to do for my job. So I needed to instead ask, what do I like researching? And to do that, I needed to look backwards. First, I looked back at my college classes. And in addition to biology classes, I also took a lot of history classes because I was fascinated with the past and the secrets it held, the stories it told, and the feeling of our world being vastly different. Then, I looked further backwards to my time in high school, and in my history classes, I most enjoyed the lectures on ancient history because I was fascinated by ancient people's simple lives, reliance on nature, and progression. And finally, I looked even further backwards to one of my favorite memories, watching a YouTube video called Mankind Rising: Where Do Humans Come From? It shows how human beings evolved from a single cell into who we are now. And in it, I most enjoyed the section right before Homo sapiens evolved. So by looking backwards through time, I was ready to make amazing self-discoveries. The first being my love of molecular biology was equal to my love of history. The second being I specifically love ancient history. And third being I was fascinated by human evolution, specifically how humans evolved from our ancestors, and could use genetics and proteomics as a way to research that in my career. Sometimes in life, you must look backwards through your past to make amazing self-discoveries. This was true for my interest in human evolution, and true for researchers' discoveries of the earliest potential hominins. And in the end, we both discovered amazing things. So hopefully, by understanding both mine and researchers' journeys and discoveries, you too can understand how to journey backwards through your own past to make your own amazing self-discoveries.